What we'll do in this session is primarily build upon the ideas that we were discussing in the last class to understand the context and to establish a framework which will help us in understanding the topic in a much more clear manner. See, these are all, whatever we will be discussing now, should be understood more as a kind of a diagnostic tools kit. Just like when you go to a doctor, he has a established procedure through which he does the diagnosis. Right? Similarly, when we, the information engineers, when we have to analyze a given system, we need a framework. Because otherwise the modern information systems are so huge and so complex that we will not know where to start. Right? If you look at anything, for example, a big e-commerce website will be given to you and you will be asked to modify it. You will not know where to start, how to understand the system. That is why what we are doing today is trying to understand the basic framework which can help us understand, analyze and later improve. So in this context, the first idea that we were discussing in the last class, which I want everyone to be very familiar with is not in the sense of understanding the entire framework, but in knowing how to apply it to a given context, is the idea of a system. So the first idea that we elaborated in the previous class was that any system can be understood as a collection of components working within the context, having 3 or 4 essential components. The essential components were, it will have an input component, the processing and the output. We said we will improve the system. We will improve the system using 2 components, a control component which will control all the other items, and necessarily a feedback. Right? We also said that for information systems, in along with all these components which are discussed in any idea of a system, information systems exhibit a special characteristic. They have one more additional component. We have discussed this in the last class. That is called storage. So information systems have an additional component called storage, in addition to all the other components which are there in every system. We also understood that there is this idea of an environment around the system which does not constitute a core part of the system, but definitely which influences the system. As in, the system will take input from this environment and it gives output to this environment. And there are many other components in the environment which will affect the working of our system. This is the first idea that we had discussed. The second idea that we had discussed is the idea of information. We had said that information is nothing but relating the hetero unconnected ideas to make a new understanding which earlier did not exist about it. First the idea. So with these 2 basic ideas, we can also define what an information system is. So how did we decide what information system is? Yeah, it should basically have all these components, and basically it generates information in this way. That is, we have to visualize, think that there are thousands of data points which are fitting to the system. This will be processed using the control, and finally what you get is information which like this. That is what an information system is. So if you want a very academic definition, we can say that information system is necessarily a system. System means satisfying this. So information system, primarily the characteristic is that it is a system. meaning it will satisfy all this. Second, what are the activities in an information system? Before processing, the processing is here. Before processing,
takes the input.
should collect, let us say. So, the main activities are, one, it should collect the information. Now see, this is not as simple as we say. Collecting the required data means that you know what kind of data should be collected. From where to collect, how to collect. From all the data that you have collected, how do you clean the data? Right? You have to take in only that data which is required for this particular system. So there should be some kind of filter here. So all these ideas are there. Collectively we call collecting the data. Then broadly say process. Now process we have meditated in the last class. So processing need not necessarily mean that some kind of the traditional idea of processing, that is mathematical calculation or something happen. Rather, the same data when the form is transformed, or the same data when it is given at a different time, it becomes information. So necessarily contextualizing the data is information. Right? So processing means contextualizing the data. The data in a context is an information. This is one. Third basic activity of an information system is this. What is the difference between any other information system and computer-based information system? Is necessarily that we can store the data. Once you store the data, it has a permanence value. Right? So we should store, we can store the data. This is again a broad area. Starting from a simple idea of how to store simple data, we have seen how to store data in files, we have seen how persistent objects can be stored in databases. Later now, this time we are studying information systems and management, where we will see across the network, right? Mega gigabits of data, how can it be stored, organized, and all these ideas. So this in itself is a very huge area. We have used only one word, store, right? One more thing here I am adding a philosophical note that data which is stored in computer has a permanence value. We keep saying it, once I said something flat. But that permanence value is very virtual. See, for example, I was reading about micro SD chips which are common. Micro SD chips which are smaller than a dime. Smaller than a dime. Can today, as of the new release, can store around 20 GB of data. A small device storing 20 GB of data. Imagine tomorrow we will have, definitely we will have, a device, whatever it may be called, a futuristic device, like a very small, or as of the size of a sand particle, which can store enormous amount of data. We say that the data is permanent once you store, but see, if you want to give a similar idea in the real world, the same amount of data if you want to store in books, it will be covered in a very, very huge building. To destroy that building takes enormous amount of time and energy. Right? But destroying that small device. So, one philosophical question which we should think, I think, is the data really permanent once you store in micro devices? All of us are frustrated once our hard disk crashes. There is no way we can get that back. Right? It is not so if you store the data in a book or something. The idea is completely different. So maybe in future we may also somebody may think on these lines. But anyway, that's one of the philosophical notes. There is one more activity related to information system that has recently come up in our area. Transmit the data. So we not only collect, process, store and give the output, we transmit the data. Please understand, one adds to the strength of the other. Please see how there is a quantum leap when one capability added to this. See, if transmission was not there, if you were not able to transmit data, then data would be localized. Now since we have the ability to transmit data anywhere across the globe or outside it also, there is a quantum leap in the capability. So the data which is stored has an immense value because it can be transmitted. Think about any web-based application. Web-based application is superior over traditional desktop application because the computing power is distributed. So you are empowering people. That is there, component is there. Right? So collectively, anything which exhibits these properties will call it an information system. Now, this definition itself should give you the idea of what is that we are talking here about. The issue is so complex. On the one hand, we have to collect the information. We said that itself is a very good idea. Processing idea encompasses from programming to application development, everything. Storing in itself a big area. Transmitting, again an independent area. So what are we expecting you to know? Definitely, we want all of you to have at least a bird's eye view on all the technologies which are involved here. So that is why I said this course is the heart of this program, wherein we will be interested in anything and everything. If you say network, yes. Java, yes. .NET, yes. Because anything and everything you talk about in our field comes under this definition. Is that very clear to everyone? So this is what we will be interested in. These are the ideas we are discussing. The third idea which we had started discussing in the last class was what is that basic components which make for an information system. We said there are necessarily 5 components which we should learn. Starts from hardware, software, data store is what I use. Rainer Turpin Porter uses our database, but I am not very clear whether we should use database for it. I use data store, right? And people, procedures. You should have necessarily 5 components. Right? We'll elaborate on this once I come to some other idea. So it should have hardware, software, data store, people and procedure. This, see, adding of these 2 fields adds a new dimension to this topic. What we are saying is, you can't completely disassociate people from information system. Information system discussion is not a dry discussion about machines or software. It is primarily about people. Who are using it? How do they want to use it? All these ideas. And procedures. Through a case study we will see how procedures are very important part of information system. If the procedures are not correct, however efficient your hardware and software may be, the information system fails. Okay? So this adds the human component. What I am trying to say by listing these 5 is, information systems has a huge human angle to it. We are not taking out humans from discussion. Right? This is the idea we had spoken in the last class. We will continue from it. I think one of the significant contributions of Rainer Turpin and Porter in their book is the introduction of an idea which clearly differentiates 2 of the complex issues in our discussion. For example, let me give an example. If some customer comes to us and says, he will not come to us and say, I won't have an information system. He will definitely say that he will have a business problem. And can we help him? Necessarily by developing a new software. The whole problem here is not just building a software, but as I keep saying, to develop and deploy an entire system. When I say system, all these ideas come. So I should worry about hardware, I should worry about software, I should worry about transmitting the data, I should worry about so many things. People, procedure, everything. So how do I start? How do I start? If you don't know how to start, you can't solve this problem, right? So, Reinhard, Urban and Potter give us a very good framework for understanding this. But they don't elaborate. I will elaborate more. They have just mentioned it and they have gone to the next idea. The idea they have introduced in their book, which is not found in any other book on information system, is clear distinction of two issues, which they call as IT architecture and IT infrastructure. They make a differentiation between these two, IT architecture and IT infrastructure.